So we study how to operate the shuttle in the closed area in a predefined room condition, and also study how the sensor works and how to use the 5G as the use case in the communication between the shuttle and the video ball on the control room, and also for using for the monitoring of the passenger inside the vehicle, and also the safe driver who monitor the system during the test. So this is a video presentation. We have in Thai language, we have the English subtitle. So let's see.
เป็นประเทศที่มีอัตราการบาดเจ็บและเสียชีวิตจากอุบัติเหตุทางถนนเป็นลำดับต้นๆของโลกรวมถึงกำลังก้าวเข้าสู่สังคมผู้สูงอายุยานยนต์ขับขี่อัตโนมัติหรือ Autonomous Car จะช่วยตอบสนองความต้องการของผู้โดยสารทำให้สามารถเดินทางได้สะดวกสบายมากยิ่งขึ้นและยังเพิ่มความปลอดภัยให้แก่ผู้โดยสารยิ่งไปกว่านั้นรถขับขี่อัตโนมัติจะทำให้เกิดรูปแบบทางธุรกิจใหม่ๆทั้งในภาคการคมนาคมขนส่งผู้โดยสารและในภาคการขนส่งสินค้าเทคโนโลยียานยนต์สมัยใหม่จำเป็นต้องมีการรับส่งข้อมูลระหว่างระบบต่างๆและการเชื่อมต่อกับสรรพสิ่งหรือเรียกว่า V2X เพื่อใช้ในการนำทางการเตือนภัยผู้ขับขี่รวมถึงการสร้างความสุนทรียะให้แก่ผู้ขับขี่และผู้โดยสารเทคโนโลยี 5G สามารถตอบสนองความต้องการในการรับส่งข้อมูลจำนวนมากด้วยอัตราเร็วสูงโดยมีความหน่วงเวลาต่ำรวมถึงเชื่อมต่อได้อย่างรวดเร็วและเสถียรเมื่อมีอุปกรณ์ลูกค้าจำนวนมากจึงเป็นที่มาของโครงการทดลองการสื่อสารด้วยระบบ 5G สำหรับรถไร้คนขับโดยคณะวิศวกรรมศาสตร์จุฬาลงกรณ์มหาวิทยาลัยและ Smart Mobility Research Center ภายใต้การสนับสนุนจากกทปส.กสทช.และ AIS โดยมีวัตถุประสงค์เพื่อ 1. พัฒนาและทดสอบความสามารถของรถอัตโนมัติระดับ 3 หรือ Autonomous Shuttle 2. ทดสอบการสื่อสารข้อมูลระหว่างรถอัตโนมัติกับระบบอื่นๆภายใต้โครงข่าย 5G 3. พัฒนาและทดสอบ Use Case หรือการใช้งานนอกจากนั้นแล้วยังเป็นการสร้างความร่วมมือระหว่างหน่วยงานและจัดทำข้อเสนอแนะการใช้งานระบบรถอัตโนมัติหรือ Autonomous Shuttle ในประเทศไทยโดยมีการดำเนินกิจกรรมครอบคลุมใน3หมวดหลักได้แก่ 1. การทดสอบรถขับเคลื่อนอัตโนมัติระดับที่ 3 ในรูปแบบ Electric Autonomous Shuttle 2. การทดสอบการระบบสื่อสารของรถบนโครงข่าย 5G 3. การทดสอบ Use Case โดยได้มีการดำเนินงานกิจกรรมทดสอบต่างๆบนรถต้นแบบทั้งสิ้น3คันทั้งในพื้นที่จุฬาลงกรณ์มหาวิทยาลัยและพื้นที่ภายในกสทช.การทดสอบรถขับเคลื่อนอัตโนมัติระดับที่ 3 ประกอบด้วยการทดสอบระบบตรวจสภาพแวดล้อมผ่านระบบเซ็นเซอร์และการระบุตำแหน่งตัวรถผ่านระบบแผนที่ความละเอียดสูงการทดสอบระบบประมวลสภาพแวดล้อมรอบรถระบบการระบุตำแหน่งระบบวางแผนการวิ่งและการตัดสินใจของตัวรถหรือ High Level Control System การทดสอบระบบควบคุมการขับขี่และการเคลื่อนที่ของรถหรือ Low Level Control System การทดสอบระบบสื่อสารของรถบนโครงข่าย 5G ประกอบด้วย 1. ระบบการรับส่งข้อมูล CV2X มีความสามารถในการรับส่งข้อมูลระหว่างรถไร้คนขับแต่ละคันเพื่อสร้างการรับรู้ต่อเหตุการณ์ที่เกิดนอกระยะสายตาของรถไร้คนขับคันอื่นและเฝ้าระวังอุบัติเหตุจากการชน 2. ระบบรับส่งข้อมูล V2N โดยอาศัยโครงข่ายสื่อสารเป็นตัวกลางในการรับส่งข้อมูลระหว่างรถแต่ละคันการพัฒนาและทดสอบ Use Case ประกอบด้วยการทดสอบทั้งหมด 5 โมดูลได้แก่ 1. โมดูลสตรีมมิ่งวิดีโอผู้โดยสารผ่านโครงข่าย 5G เพื่อแสดงผลที่ศูนย์ควบคุม 2. เว็บแอปพลิเคชันและการจัดการและแดชบอร์ดสำหรับสังเกตการณ์ 3. โมดูลแจ้งเตือนอุบัติเหตุ 4. โมดูลเฝ้าระวังอาการหลับในโดยอาศัยการประมวลผลวิดีโอสตรีมมิ่งดวงตาของผู้ขับขี่ 5. โมดูลการนับจำนวนผู้โดยสารนอกเหนือจากนั้นโครงการยังได้ดำเนินกิจกรรม Demo Day ซึ่งประกอบด้วยกิจกรรมสาธิตการทำงานของ Autonomous Shuttle ในพื้นที่จุฬาลงกรณ์มหาวิทยาลัยโครงการทดลองการสื่อสารด้วยระบบ 5G สำหรับรถไร้คนขับสามารถเกิดขึ้นได้จากการบูรณาการความร่วมมือทั้งจากภาครัฐภาคเอกชนและภาคการศึกษาโดยผลลัพธ์จากโครงการดังกล่าวได้ยังให้เกิดนวัตกรรมการพัฒนารถไร้คนขับและการทดสอบการสื่อสารผ่านระบบโครงข่าย 5G โดยคณะนักวิจัยชาวไทยซึ่งส่งผลกระทบเชิงบวกต่อทั้งโอกาสและมูลค่าสำหรับอุตสาหกรรมขนส่งยานยนต์โทรคมนาคมและอุตสาหกรรมที่เกี่ยวเนื่องต่างๆภายในประเทศไทย
Okay, so this is brief introduction, actually not brief, but about the overall the project that we did. And this is the colleagues, our partner in the project that's come from various departments from Chulalongkorn University. And okay, in the project we developed the software on top of the open source software on the autonomous shuttle platform that we use in the project, and also we developed for the external human-machine interface to communicate with other people. And for example, when we drive, we can show the mode of driving, manual or autonomous mode. And also in this project we have 3 vehicles, and we have to test it together to see about the capability of the telecommunication that we use for the bandwidth and latency. And also we test in Chulalongkorn University and also in the BTC area like this. And we have the dashboard that we can tell about the position, the speed, batteries, condition, driving mode, and also we can see the camera from the front and rear, and also even the later point cloud to the dashboard. So we can see about how it's going on when we operate the vehicles. We can select even 1 or 2 or 3 vehicles to see about the conditions. Okay. And in the 5G, we have to test for the performance of the network, for the throughput, latency, and packet loss. And also in the use case, as I mentioned in the videos, we developed the system to monitor for the safe driver that he is sleepy or not, and also count for the number of passengers and monitor for the passenger inside the vehicles using the video analytics. And we have demos in July in BTC, and this is in the end of the project. Many of our colleagues today joined that day too. And okay, what is the update activity that I'd like to mention today? It's about mainly we do into group of activities. First one is about the SAILINT project. First one is about the development of incident database system for demonstrating testing. And the one is a study on operation and comfort levels of autonomous shuttle service in Chulalongkorn University. And another 3 is a master thesis that is going to be defended this month, actually next week. The first one is about external human-machine interface between autonomous shuttle, bus, and pedestrian in zebra crossing scenarios. Second one is about the development of decision-making and long-haul planning for autonomous vehicles to mitigate pedestrian crash. And the last one is about the development of collision avoidance system for autonomous vehicle by using the camera-based object detection with cellular network. And today I will give some example of these activities. The first one is about the incident database. We can record for the mileage of the test, and also about the percentage of the driving mode. Okay, like this, we can know that in the trip of the test, we can know percentage of the autonomous and manual that control the vehicle. We also can see that for the location test that we have the accident occur in which location of the route that we test. And for example, for the star, we have some collision occurs, and then we can see this data later when we connect to the database that we record during the test. For example, this is another one that we have another condition during the test. And we can see, for example, the acceleration. We can use acceleration as the threshold for the trigger that some incident may occur. Also, we can use the area base, and also the operation condition base, as well as a criteria to decide that this is incident or not. For example, this one, this is the real case that occurs during the test in BTC at night. We found some motorcycle that parked on the way that we tested. So from the acceleration, it detect that, but we can detect from the area base that we have some objects in front of the route that we are operating. And also we can see that we have the database that this is the motorcycle that parking in the straight road. We try to have the classification for the condition of the incident. Another one is in Chulalongkorn University, we have the shuttle bus cut in front of our vehicle like this. And actually we can go to see the video what occurred at the time. This one just showed the picture. So this is the type of the bus on the straight road, and actually it's a cut in. And this one, because we have a safe driver that detected it before, so the acceleration is not that high, but we can detect from the range of that bus that cut in front of the vehicle, so we know that it's an incident. And another one of the conditions that we can detect is that when the safe driver control manually is considered that there's something happening. Okay, and another one that we did is about the ride comfort level of the passenger. We try to analyze for the acceleration occurred during the route that we test, and we try to plot for the acceleration in the two axes. And we try to match it with the some standard or the scale of the acceleration that occurred in the comfort public transportation or in the normal driving zone, and see that our data is fit into the area or not. And it's used to be like one of the feedback data that we can use to improve our operation of the autonomous shuttle. And we also have the questionnaire to the test sampling that sit in our car. So we have a test them with stereo condition. One of the example is that we test between different speed of operation, like 20 or 15, and ask them that do they like that or do they not dislike that or not? And we have some data like this. And also we even fix the seat that our sample sit in the car, in the bus, that is in which number, and we also can see the score that it related to the seat position or not. And but what we found is that it's not that related for the test that we did. But we need to have more people to trial with us to have more data. And another one that is about the EHMI that we found that in our university we have many pedestrians crossing the street, and we would like to communicate with them. So we try to find out about the best combination between the color, wording, or the symbol that it can communicate to the pedestrian more effectively. So we have done something with the simulation first for 100 people, see the videos and click for the response that they understand the sign. And then we did the real test, like we put in the real car and we have the real people. But they're not crossing, they just decide that they understand or not before crossing. Actually, the vehicle is braking, but to be safe, they not actually cross, but we check that they understand or not. Okay, and lastly, for last page, is about our plan for the next step. It's about the pilot test in our campus. Before, we have the running test in this route a lot, but we need to extend this to the new area that will be more practical for the passenger to use, because this side is the Jamturi Square, is an MRT station, and people that come from this ways maybe would like to go to this area, and they can take our shuttle to this area. So we extend our service about 2 kilometers for this route, and we increase the operation speed up to 25 kilometers per hour. And also for the operation, we decide that we still need to have the safe driver, and safe driver is one to control the operation, monitor the operation, and also open and close the door. And we plan for the pilot test in a few months from now, maybe from October. We try to do it in this year. Okay, so this is about they updated. Thank you very much. Sorry for that. And we would like to welcome our new colleagues or our colleagues to update your activities or your works about the CAB. You can have a stage for you. You can share your talk. 5 minutes or depends on your information. But we would like to have more updated from our participants.
Yeah, thank you. So if you would like to update your activities or if you would like to share something, please connect with our staff, the white shirt student, and at the back. Yeah, so we will be helping you over there. Yeah, so they will be helping you setting up. So I think we will continue with our schedule, and I think you have like 40-20 or either 14-20 or 14-50. That will be a good period that you can share. But if you have any thing to share, please connect to our helper in the back, and they will be helping you preparing for the presentation. So I think from the schedule, we're gonna continue to the next activities. So I think I would like to invite Mr. Yu Shen-san from Neolix present in the title Unmanned Air-Force Vehicle in Logistics Industry. Please welcome Mr. Yu Shen-san.
Sawadee. Good afternoon, everyone. Today, my topic, I'd like to share the real use case in China about the express and the delivery industry. In the beginning, allow me to introduce my company and introduce my industry in China. I'm Yu Shen-Zhang, come from the Neolix, China, and we are an autonomous vehicle company. And also, we are the first mass product autonomous vehicle in the world. We focus on the level 4 autonomous vehicle. And you can see the background, and we say we are the world's top level of the autonomous vehicle, and also we are from the beginning. Sorry. Okay, from the beginning, I'd like to share one group of data. In 2022, in China, had 400 million delivery orders per day. And in the delivery industry, average age of the delivery driver, they're more than 14 years old, and their per year salary need 10,000 Chinese yuan. And for the on the roads, have 30 million of the minivan and some electric car driving on the road cause many accidents. And we forecast in 2025, we have 1 billion orders per day. And also, we planning in 2025, the autonomous vehicle will hybrid with manpower, like human resource work together. In the beginning, I shared the video about the autonomous vehicle, how could work with the human together. Okay, that is okay. It seems like I have no sound in this video. I'd like to, when the video playing, I can introduce about our autonomous vehicle driving on the public roads. And under you can see this is HD mapping and with mixed back of AI. We have the real use case use the autonomous vehicle to transport the fruits and some market food in the market, in the crowds and narrow space. This is our coffee vehicle. The people in CBD area, they can purchase the coffee like Dolphin machine, yeah. And this is the cargo function. It's used for the delivery the big stuff. And we also have the multiple boxes used for the delivery, the multiple deliveries in one time to solve the last 1 mile. And at the night, the autonomous vehicle can do the patrol function in 24 hours. Okay, this is the specification of our autonomous vehicle. We have the middle range 32 line LiDAR, and we use a multiple sensor, for example, like a camera. And you can see we have a lot of camera around. And the last version, we still have the ultrasonic radar. But now this version, and we not use this kind of solution because we think the camera and the LiDAR fusion data will be the autonomous future. So this video to show our technology, we have the full self-developed, and how could we put every module in one small vehicle. This is our self-designed 360-degree camera and with the LiDAR together. And our autonomous vehicle passed the Europe standard, and also we got the TÜV certificate, and also passed the ROS standard. The different brand and different company we cooperate, we show what before. We use the Orin, the NVIDIA Orin system. This is the world highest top computing platform. And our autonomous vehicle can have the self-learning ability according to the very complicated situation, and can safety cooperate with any driver or another cars. We have the 4D perception, use the 3D real world plus the timeline to do the 4D perception to ensure the autonomous vehicle can focus another vehicle's action. This is our timeline of the different generation of products. We have the first product in 2018 the year, and in this year in Thailand we have the X3 Plus vehicle, and in China now we have the X3 Max, X3 Pro, and the X5 vehicle in the future. Now the X3 Max and the X3 Pro is testing in China now, and we are the first got the driving license in China and in Beijing. we are the new list 8X001, the first driving license. And also, we in this year, we got almost of city driving license, for example, Shanghai, Beijing, and Shenzhen, some multiple cities. And we forecast in 2024, this year, we will got the China full country driving license. This is the delivery model of the different stage of the autonomous vehicle. For example, from the factory to the warehouse, and normally they use a big truck to deliver it. But from the warehouse to the distribution center, for example, our X5 design for the middle range distance from the Chonburi or from the Pattaya, you'd like to deliver something to Bangkok, and we in the future will be use X5 to solve this kind of middle distance range. For example, arrive the Bangkok distribution center, and we still have the 15 kilometers or 100 kilometers distance to the final site. So we will use X3 Max, this kind of smaller, but also the speed will be lower. This kind of vehicle to delivery for the like a business site delivery. And the final one is about last 1 mile problem. Now, normally the Thailand use a motorbike driver or use a minivan or use a pickup car, and we will use the X3 Plus function because X3 Plus is more smaller and more smart for the crossing in the alley, crossing in the narrow places. And for our products, we have cooperated with the SF, like FedEx and DHL and multiple delivery company in China as well. This is the video we show the world first mass product smart factory. We have the center server to control the manufacturing process, and in the manufacturing line we have the micro camera to control the manufacturing quality. And every vehicle before launch the delivery to the customer will pass the multiple testing and the checking. This is the camera remark, the data fusion data remark process. And you can see many QR codes there, and to ensure our fusion data, especially like LiDAR and camera data, is exactly matched. And this is crossing the water and the slope. Before the vehicle delivery to the customer, we passed the 16 items of testing. This factory located in China, Jiangsu, Yancheng. Yes. And this is a waterproof about the speed bump, S road, traffic lights, crossing. And you can see from the video, you can see the multiple functions. For example, I introduced about the coffee car. We also have the ice cream car, can keep in freeze. And there in Beijing, there some, I think this must be very popular in Thailand. And also, we have the cooperate with Coca-Cola and KFC to sell their products. And for the ICBC, we move the ATM to the vehicle, the mobile ATM. And in the future, we like to cooperate with the Thailand many university to deploy our education vehicle. That is have our hardware, and we have the textbook to share our knowledge to the universities. So this is over the real cost of the delivery vehicle, and per order, our cost only 0.4 yuan is 20 baht delivery cost. But normally in China they need 1.2 yuan, almost. Sorry, it's 2 baht. That is another delivery need at least 10 baht. So this video is a real case how the autonomous vehicle running in public road to send the stuff. We use the multiple sensors to ensure they have no blind area. And this is fusion. Use the camera plus the LiDAR fusion. You through the Orin system, ensure our computing enough have the AI power. And we have the module design, can change the module and can change the different function to ensure the product standard is same. And also we use the switch battery system to ensure we can run in 24 hours. The customer, they only need 3 minutes to switch the battery. This is the real video running in Beijing. From the technology side, we have the full self-design. We call UWISE. This is our self-designed computing platform and use the Orin GPU graphic computing unit inside. And also about the sensor, about the electric. The electric also, we have the factory to manufacture electric for ourselves. And also about the power system. And we have the remote driving center. The user can can monitor the 20 vehicles in one time, just sit in the office and check every vehicle running now and the real picture and what the machine, what the function. And also we have the cloud control. The customer can use a mobile phone to know where is the vehicle and for example, I like the big vehicle, I like to purchase, but the vehicle I don't know where is that. The customer can use the mini program and to order the vehicle to use service to you. This is our autonomous driving. We call the AD 3.0. This is for sure is the next generation of autonomous driving. They have the key technology. First one is about have the 4D perception. What is 4D? We already know that the world is 3D and we plus the timeline is the 4D. So it means that our vehicle can forecasting about the future things, about the, for example, you are moving on, the vehicle, the AI will forecast 1 second later where you are, 2 seconds later what your action. And about the 3D reconstruction, that's why is we rebuild the world. For example, the camera see is 2D, but we use our technology. The vehicle is running and we will use a 2D picture to rebuild the world to be the 3D. So that is a reconstruction. About the reinforcement learning is we use machine learning function. For example, today the vehicle meets the accident, emergency accident, but the vehicle has the action or the program is to ensure this accident don't happen. So the AI will keep learning and to put the key technology, key data, and to self-learning, upload to the side computing, and to ensure the AI meet next time. Every AI, every vehicle will learn from this one.
In a way, maybe I need to iterate with, yeah, so,
Oh yes.
we need to proceed to the next, yeah.
Okay. Okay, it's about the last, about you can see the real camera, and about according to this, a lot of people trying to test this vehicle.
So the situation in Thailand is not so exciting anymore.
Thai people is more kind.
You will stay there.
Okay, my presentation finished. Okay, thank you very much. Thank you.
Thank you very much. So, such an exciting work, yeah. And yeah, I think we start to have more and more collaboration in Thailand. So it's very good. So may I invite the next speaker to prepare the computer?
My turn.
Mr. Ronald, during which I would like to share with you his background. So Dr. Ronald Wu, he has extensive professional experience